Hey everybody, it is June 15th, 2022. You know what time that is? That means it's time for our monthly meetup. Couchbasers, welcome everybody. Welcome internet for all you attending. My name's Aaron LeBeau. With me, I've got my awesome friend Nitish. Nitish, how are you doing?
I'm doing great, Aaron. How's it going for you?
It is hot. It is the summer and it is hot here. So one of the coolest things you could do is just come cool down with us and hang out. Now I've got a special for you, man. So normally we have a bunch of people come out and talk and stuff. This month we're doing something different and special. We're having a party. We're having a come out party because we've got something cool to announce that just came out. But before that, I do want to get to a couple other things that we have before we talk about our big party we're going to have today. We got someone coming on to talk about some cool things that we have. I'm really excited. So let's get started with this. To start out with, one, we've got a big announcement. Capella, which we've talked about before. It's pretty awesome. It's pretty great. It's a database as a service, cloud offering. It makes you zero to hero. You can go from having nothing to having a full database service up and running, your own cluster in less than 20 minutes. It's really awesome. We now have support for GCP and beta. This is pretty great. So there's a big announcement over in our blog if you want to go ahead and read, and you can actually get part of our beta. So if you want, there's right here, we have some links in here. You can go kind of go through and watch that. This will be coming out later on. I don't have a date that I want to say, but I think I know when it's coming out, but if you read the blog article, you'll find out it's a very new feature. The very new feature. You don't need a time machine. You don't need a DeLorean, to do this. It's coming out in the very near future. So no time machine required. It's going to be awesome. So for GCP customers, if you've been waiting, your wait is very, very short, about this short. And you're going to have support. It's going to be awesome. Now, the other thing, because everybody probably knows on this by now, that I am a huge fan of the mobiles. I like mobiles. I've got all kinds of phones here. I mean, where's all my phones here? I've got phones. Look at all the phones. I've got phones, because I'm a mobile developer. I love the mobile. So we have super awesome. Capella is announcing app services. What is app services? I know that this sounds, what is that? Well, app services is the ability to do some of our cool features in mobile, Couchbase Mobile. So specifically our sync technology. You might know it today as Sync Gateway. Well, app services now is going to allow you to do that syncing technology in Capella. Holy cats, this is amazing. This means that I can go from having nothing to having a full cluster of Couchbase running and having sync capabilities for mobile all in less than 20 minutes. So this is also in private preview beta. So there's a great blog article on here that Mark goes through and explains this. And you can sign up. There's a little link at the bottom here. We explained the infrastructure. I'm not going to get too nerdy into the infrastructure here, but it's pretty great. I can tell you right now. And you can see we have a little tutorial, and there's a little link here. So you can go here. You can get in touch with us if you're interested in checking this out. It is in private preview right now. It is pretty amazing. In fact, it is so cool, I have it running here. Now, I'm not going to go through everything, but I'm here to tell you I've played with the bits, and I'm here to tell you that it's awesome. We're going to be updating all of our documentation and developer portals so that when this actually GAs, which is also, you don't need a time machine. It's coming very shortly. Like I said before, it's about this close to being done. When we GA, you'll be able to go to the developer portal and you'll be able to get tutorials that walk you through all this, which is kind of cool. Now, since I'm talking about the developer portal, let's talk about what the party's about. So that's this month. We're doing something a little bit different. We're having a party for the come out release of 7.1 Couchbase Server Neo. Neo is super awesome. It's so awesome, I'm wearing my glasses here. Now, I know these aren't like the Neo glasses, but this is the closest thing I have. So sorry, folks. But what is Neo? Neo is a full dot release of super cool awesomeness. What is super cool awesomeness? That sounds very untechnical. Most companies would take this release and put it out as a full release. This would be like, product 8.0. But not at Couchbase. We're going to give you a ton of value in a dot release. Now, how much stuff? Well, it's a ton. So I'm on the developer portal, and we have some highlights of kind of my favorite features, I think, that came out. There's awesome stuff. I'm going to get to storage engine a little bit, but we have changes in analytics. So there's new tabular analytics views that are supported. There's high availability, so you can fail over. A couple of big features I want to call out real quick. One, wait for it, Mac ARM processor support. So that is pretty awesome. That means if you're running one of these fancy new Apple laptops, you now can run Couchbase native. You can basically download a Docker image. It's out on Docker Hub. Just go ahead and look for ARC64, which is the Linux 64 packages. And you can literally get yourself up and running with Neo on your Mac. Now, it doesn't stop there. It doesn't stop there. Because it's ARM64 support, that means if you're in AWS and you like to save some money and you're looking at the price for performance per watt. Now remember, ARM is all about power efficiency, right? So when we talk about the price per watt, the Graviton processors in AWS are the best. They're ARM-based processors. We now support running Couchbase on Graviton, basically. So now if you want to run in AWS on ARM, Couchbase Neo does that. That is pretty awesome. But it doesn't stop there, bud. It doesn't stop there. Get this. How about if you have like one of these little fancy Raspberry Pis, like these new ARM64 based, like the Raspberry Pi 4. You can run Couchbase on a Raspberry Pi. Literally, I literally have one. It's I can't reach it from my desk here, but it's over there. I promise you, I'm pointing to it. It knows I'm pointing to it. It's over there, and it runs Couchbase. That is pretty awesome. So the ARM story is pretty great. So if you are a embedded developer, you're looking to save some money on price per performance watt, or if you're looking to have your fancy new Mac and run Couchbase on it, we got your back. That's pretty great. A couple other things we do here. There is new support for in the JavaScript user-defined functions. There is more new stuff in there than I have time to talk about today. My recommendation is to walk over to what's our What's New article that we have. So this is posted out on our website, and it highlights all the new features we have going on. I just talked about the ARM support there, and it's in here. The user-defined functions is pretty big, and analytics. Analytics has more new things than you could shake a stick at. So if you're an analytics customer or you're over there looking at the user-defined functions, it's pretty great. User-defined functions, for those of you that may not have missed one of our previous talks on this or haven't looked at them, they're like store procedures, but they're Couchbase. So they're like, of course, better. And they're written in JavaScript. I mean, JavaScript, according to like Stack Overflow, is the most popular language on the planet. It's almost more popular than English. Okay, I'm just kidding. But according to Stack Overflow, it's pretty close. It's like, here's English, and then here's JavaScript. So I'm just saying, it's pretty popular. We support it in user-defined functions. So that is pretty awesome. Now, in this release specifically, you can now run nickel queries or SQL++ queries in your user-defined function all through JavaScript. You got to check it out. So I highly recommend going through and checking out our What's New document because there's just so much stuff. And of course, this will link to eventually to our docs page. In our docs page, we have a full list of like the release notes, and that's pretty bonkers crazy. Now, before we get to our speaker, I do want to call out something special. We're having Connect 2022 this year, and that's happening in a little bit here in October. We are looking for people, anybody out there that wants to present at Connect. So if you have something cool you built with Couchbase, you have something that you're really excited about and you want to show off to the world, go over here to Call Paper and sign up and basically submit your story. If you want, you can, if you say, for example, you think you have a good idea, but you want to kind of go through and maybe talk to somebody like maybe me or Nitish about it. Well, I've got some really cool news for you. Community, we have Discord. That's right. So say, for example, you're trying to, got to get my mouse here, get the Discords open here, and I'll show you real quick here. So this is our Discord. So Couchbase is in Discord. So say, for example, you want to do that super cool, awesome talk, but maybe you want to go past and talk to somebody about it. You can go in Discord. You could post some questions about it. Maybe post your idea and get some feedback on it. Either way, we're there. Everyone's hanging out. The .NET community, if you're there, Python, we've got all the different languages supported, including my friends in mobile. We have a whole mobile channel over here. We've got events, so if you want to figure out what's going on. Also, when we live stream, you can get live updates. This is pretty awesome. awesome. So if you want live support, or I wouldn't say live support, but if you want to hang out with the community live, come over here. Now, of course, we always have the Couchbase forums. That's not going away. So if you want to also ask questions, you can also use the Couchbase forums. Now, that's a lot of stuff I just talked about. But what I'm really excited about, and one of the brand new features in Couchbase 7.1, and it is worth bringing someone super smart on to talk about, is Couchbase Magma. Now, Magma is a new storage engine. It is worth your time. Literally, Magma is so awesome that after you're done with this video, the very first thing you should do is go and download Couchbase Server 7.1 Neo and start a POC right now, because it is that big of a deal. It is game changing. It is world breaking. It gives you basically a massive amount of cool awesomeness, and it's going to change the way you think about Couchbase. I promise you this. And I know that I'm hyping it up. That sounds like it's a lot, but it really is that big of a deal. So with that, I would like to bring our speaker on today. Shivani, are you available to come on and talk to us for a little bit?
Yes, hi Aaron. Hi Nitish. I'm here. Thank you for
Awesome. Awesome. Well, I am really excited about Magma. I think this is honestly, this is like the biggest deal since collection and scopes, in my opinion. It is that awesome. Now, I know that you have a really cool presentation where you could tell all of our viewers, and obviously there's also people watching on video on demand. So if you're watching video on demand after the stream, please stay tuned. That's going to be super awesome. And then we'll have some Q&A afterward. How's that sound?
Yeah, sounds good to me.
All right. Well, with that, I'm going to sneak off the stream for a little bit so you can go ahead and talk to us and show us what Magma is, because I'm excited.
Great. Thank you, Aaron. So I guess I should go into present mode. All right. So hello, everyone. As Aaron introduced me, I'm Shivani Gupta. I'm in product management, and I lead up some of the core server engine development. So one of the things that the team in engineering has been working on for the past couple of years, if not more, is a new storage engine. So a new storage engine is a pretty big deal for a database to develop. It takes a lot of effort. It's like changing the engine of an airplane, basically developing a new engine altogether. So we did it, and we finally have launched our new storage engine known as Magma. So that said, the old storage engine, which some of you who already use Couchbase might be familiar with, which is called Couchstore, is still there. So the new one doesn't eliminate the previous one. So so now you basically have a choice of two storage engines. So let's see why. Let's begin with why we went on this project to build a new storage engine. What was the need? So Couchstore basically was a data storage engine which was designed for providing persistence for a high performance memory oriented database, which is what Couchbase initially started out as a memory-oriented database, very fast sub-second access and storage when accessing data primarily from memory. So this served us very well for a large number of use cases, especially the caching use cases. But as our popularity grew, customers wanted to do more with Couchbase. They said, we really love you for our caching use cases, but can we consolidate our other use cases, which have larger amounts of data? And it's not possible to store everything in memory. So memory accessing data primarily from memory becomes expensive. And also, these use cases don't necessarily require memory speed. They said, if it takes couple of milliseconds to access from disk, it's okay for this use case. I do not need sub-millisecond memory speed, so I don't want to pay for memory. So some of these things where users really wanted to store large amounts of data at a low TCO, and we were hearing this a lot, and this led us to launch this initiative for a new storage engine, which we have now called Magma in 7.1. So It solves the problems of high data density, better disk access performance, as well as leveraging higher end hardware. If you put, more expensive drives or SSDs or NVMe SSDs or machines with large number of cores. So this new storage engine can drive your higher end hardware better. So essentially, this allows Couchbase to become a high performance disk oriented database for large volumes of data. And this is why, as Aaron said, this is a big game changer for Couchbase. We were never perceived as a contender for these kind of use cases because it was simply too expensive to store that kind of data. So, we used to require 10% memory to data ratio at least. And with Magma, this drops down to 1% memory to data ratio. So just to put this in perspective, if you have 1 terabyte of data on disk, you just need about 10 GB of memory to store this data and run an operationally stable database. Previously, you would have needed 100 GB. Not only that, now you can store more data on a single node. So you can store 10 terabytes of data on a single node. And you can do so with just 100 GB of memory because of the 1% data ratio. So previously, you couldn't even store this volume of data on a single node. So, naturally, for these very high data density use cases, this Magma dramatically reduces the TCO. And, it's a game changer for our customers, game changer for us. It's a really a big innovation and big thing for us to add to Couchbase. Not only does it increase the data density, Magma also enables you to access data from disk faster because of the way the engine is. And we'll look at, briefly at why we are able to do all these magical things. What's the secret sauce here? So we notice 4x throughput improvement at a sustained rate, especially for write-heavy workloads. Also much better disk read latencies with Magma. And as I briefly mentioned, we are able to scale up better with high-end hardware. So oftentimes customers will say, well, disk speed is fine, but if I am willing to pay for higher end disk drives such as NVMe SSDs, will you be able to scale with those? Are you able to reduce my read latencies with those drives and provide higher throughput? And the answer is yes. So the way Magma is architected, it can make use of better hardware and saturate it. So this is just a quick example of, I think by now you might be seeing this already, but it helps to work through an example. So why TCO reduction is such a big deal? So essentially, you require 10 times fewer servers on average, right? I mean, and this is directly a consequence of the memory data ratio reducing from 10% to 1%. So pre-Couchbase 7.1, you needed minimum 10%. And now with Magma, you just need 1%. So let's work through an example. Let's say you've got about 100 terabytes of data to store in Couchbase, and you've chosen the M5D 8X large instances on AWS. And these come with about 128 GB RAM. So say roughly you're giving about 100 GB RAM to each Couchbase server. So what this means is that with 100 GB RAM, with prior to 7.1, you could have maximum stored about 1 terabytes of data per node. But now with Magma, you can store 10 terabytes per node. So this straight away brings down the number of servers required to 10 from 100, and obviously a corresponding saving in server cost. This example doesn't include the EBS cost, which is separate. So, EBS naturally, to store more data, you have to attach more storage to each server. So the EBS cost is still there, but at least your server cost reduces 10 times. All right, so now let's talk about the secret sauce behind Magma. So all this sounds like a lot of goodness. How did we accomplish this? So essentially, Magma is based on a combination of cutting edge storage technologies for databases. So it's not just one simple way of storing data, which some of the off-the-shelf databases do by using engines like RocksDB as the storage engine. So we've sort of combined the best of several different technologies. The two main ones are log structured merge trees, also known as LSM, as well as separating out the values in a log structured object store. So we maintain a lot of different indexes, as LSMs, actually a couple of different indexes, because we need two different access paths by key, and we also need to access the data by sequence number for streaming. So we maintain a couple of different LSMs, and then we store the values on a separate log structured object store. So as in storage engines, efficiency really matters. So people often calibrate storage engines by write efficiency, read efficiency, and space efficiency, and the metric is amplification. So you want to reduce write amplification, read amplification, and space amplification. So to work through one example, write amplification is essentially the amount of data written to storage divided by the amount of data actually written to database. So let's say you were writing a 1K document to the database, but because the database had to maintain a lot of different data structures, it ended up being 10K bytes written to the storage. So that's a write amplification of 10. So, that's the definition of this term. Similarly, read amplification would be how much do you actually have to read on storage for, say, returning a 1K document. And space amplification similarly means that, if my incoming data set is, say, 1 terabyte, how much does it become on disk? Does it become 2 terabytes, 3 terabytes? So that measures space amplification. So a good storage engine tries to reduce all these. And with Magma, we've dramatically brought down all these three, and hence are able to, provide all the value that we described previously. So again, the point reads efficiency is related to read amplification being reduced. The other thing I want to mention is we also have a write ahead log at each vBucket level. So those of you who are database old timers know that the relational databases always had a write ahead log, which helps to acknowledge writes faster, and reduces the latency of your writes, because a write ahead log is just a append only log, and the write doesn't have to percolate through all the data structures. So each vBucket is like a shard in Couchbase. So each shard has a write ahead log, and hence we are able to reduce the latency for our persistent durable writes. Our default writes are asynchronous, so those are returned as soon as the write is written to memory. But we also have durable writes, especially used in our transactions. And for those, having the log really, write ahead log improves performance. The other thing I want to mention is about compaction. So compaction needs to happen in any storage engine, because over time there is some garbage which collects as you update the value of a key. So let's say initially the key's value was your address was somewhere in Chicago, but then you moved and you updated the document with your information with your new address in Boston or something, right? So the Chicago document becomes garbage because ours is a copy on write or append only kind of system at some level, right? So we don't modify data in place. So this process of removing garbage is called compaction. And with the previous storage engine, the compaction algorithms were different. They were more, more global, like the whole shard was compacted in one go. Whereas with Magma, the compaction is more micro. It's smaller, small incremental compactions that are always going on in the background. So there's not one large mega compaction. So there are a lot of different files that are involved in this data structure that I'm showing on the right. So there's a lot of compaction that's always going on in the background, and this it has twofold benefits. One, it frees up space constantly, so it reduces overall space amplification. And two, because it's going on constantly, it has less impact on your front end workload because these are smaller compactions. And also, it can uh, use IO parallelism better. So, NVMe SSDs provide a lot of parallelism, and we are able to tap into that parallelism with these micro compactions. The other goodie which comes with Magma is that we have improved our compression to be block level versus single document level. So JSON documents tend to have repeated labels. Hence, if you compress multiple documents together, you can overall improve ratios of compression. And with Magma, we are able to do that now with block compression. So it's a lot of re-architecting of sort of the guts of our data store, and that's why we are able to do all these big improvements. This is a lot of numbers on a single slide, and you can look at it later on and stare at the different numbers, but this is just like a summary of the comparison between what Couchstore, which is the pre-Magma storage engine, and with Magma, how have the numbers improved? And we've been talking about some of these already. So memory to data ratio, 10x improvement. You need 10x less memory. Minimum data size per node. It used to be around 3 TB. That also, we used to sort of get a bit worried when customers pushed it to 3 TB. But now you can store 10 TB. So pretty big improvement there with more than 3 times. Throughput, like I said, it's about 4x improvement at a sustained rate for write-heavy workloads. Tail read latencies, so these are your 3.9 read latencies for disk-heavy workload. Again, we're able to guarantee less than 10 milliseconds for 3.9s on regular SSDs, so that's a big improvement from what we were able to do previously. Durable writes, if you recall, I mentioned that durable writes with persistence, their performance has improved because of the write-ahead log. So again, we see more than 2.5 times improvement in throughput and 2x reduction in latency. So compression on disk, like I was saying, with Magma, we are doing block compression versus single document level compression. So overall, so the compression ratio improves from 30% to 50% with Magma. And space amplification, which is basically how much of disk space you require to store X amount of bytes into Couchbase, has reduced from 3x to 2x, so which is 33%. So overall, the effect of compression and space amplification now brings us down to roughly requiring similar amount of disk space as incoming data. So let's work through this example really quick. So compression on disk is 50% for Magma, space amplification 2x. So roughly both these, when you add, it's about 50% disk space improvement. So Couchstore, if you had 1 TB incoming data, after it got compressed, it became 70% of its original amount. Sorry. And with space amplification, it became about 2.5 TB. With Magma, after compression, 1 TB becomes 500 GB, and with space amplification of 2x, it becomes about 1 TB. So overall, you see a reduction in the space of 50% from what you required previously to now. So all these also add to your TCO savings. Not only do you need fewer servers, you need to attach less storage for the same amount of data. And storage, and especially in the cloud, EBS storage is expensive. So all these really help in keeping your bills lower. So some general considerations on how low you should go into memory residency and data density per node to with if using Magma. So like we said, you can go down to 1% memory ratio, right? But you should be mindful if there is a subset of your data set which is your working set and you do need in memory speed, you still want to keep that in memory. So you don't have to go as low as 1%. If you have, say, 20% working set for which you absolutely need in memory speed, and for the other 80% you're okay with the speed, then you still want to allocate 20% memory to data ratio. So it's really your call how you set up your Couchbase cluster. And again, in the amount of data on each node, we are allowing up to 10 terabytes, but doesn't mean you have to push it to 10 terabytes per node, because the factor that you need to consider is rebalance time. So if you upgrade your server and you're doing a swap rebalance or adding nodes, the data from this node has to move to another node. And 1 terabyte of data approximately takes 2 hours to rebalance. So if you're going to put 10 terabytes in a node, it could take 20 hours to rebalance. So we are working on some, pretty big features to improve rebalance time, but currently in 7.1, that is the time it will take. So, choose your data density per node as per acceptable SLA for your rebalance, which in turn impacts your SLA for upgrade. All right, so how do you use Magma? So I guess you're probably convinced of the benefits of Magma by now as your storage engine. So now the next question is, okay, how do you use it? So once you set up your Couchbase cluster, you can select and you create a Couchbase bucket, right? So that's how you get started with using Couchbase. You create a bucket. You can select Magma as the storage backend from the UI. So it's basically a bucket level selection. Of course, you can select it from the REST API or CLI or any other mechanism you use to create your bucket, but it has to be selected at the bucket creation time. So I'm just showing a screenshot here of the add data bucket UI. So it gives you a storage. So you say a Couchbase bucket, which means it's a persisted bucket. You choose between Magma and Couchstore. So I have chosen Magma here. Magma does require a little bit more minimum memory. So even though overall it requires less memory as your data grows, but its minimum memory requirement presently is a little bit higher. So you need 1 GB. And then, we default to full ejection. Ejection is basically as your data size grows larger than what fits in memory and new data is coming in, what do we eject from the cache to make space in the cache? We do provide two ways, value only and full. In full ejection, the keys are also ejected. In value only ejection, we keep the keys in memory for your entire data set. So for Magma, by default, we recommend full, because you don't want to run out of memory if your data ratio is 1% if your memory to data ratio is 1%. But it's really up to you how you do your sizing. If you've given it enough memory to hold your keys, feel free to use value only ejection. It does have some benefits, as you can read up in our blogs and on our documentation, but you don't have to. So that's something about how you can get started. And once you create this bucket, you just start storing your data as you would in a normal Couchstore bucket. And, you are essentially using Couchbase with Magma at that point. This is sort of like some general guidance for when you should choose Magma versus Couchstore. Eventually, there'll be a day, maybe in 2 years, 1 year, when Couchbase will say, hey, just go use Magma for everything. But for now, we're not going to force you to use Magma or to migrate your existing buckets. If you're already a Couchbase user, you don't have to take your existing Couchstore buckets and migrate them to Magma. So However, if you were sort of experiencing the pain points for which Magma is developed, I would highly encourage you to migrate your existing data buckets to Magma, as well as use it for all your new use cases. If you're okay with disk speed, you can give it less memory and use Magma. And high data density, like we said, if you have large amounts of data and your main goal is to reduce TCO, or you have transactional use cases where the performance of durable writes really matters. So in those cases, you should really be using Magma, even for your existing use cases. Now, for new use cases, the only times you might want to consider Couchstore for now is, I'm going to walk through in the reverse order on this list. In 7.1, we have not certified FTS eventing and analytics with Magma buckets, but this is coming soon. But if you need to use it today, then maybe you still have to stick with Couchstore for your new use case. But in the next month or so, once we announce 7.11, this should be certified. The other one is large number of buckets on low-end hardware. So like I was saying, Magma does require slightly higher minimum memory. It requires 1024 megabytes / 1 gig. So, if you want to create 30 buckets, it is a pretty high memory, whereas with Couchstore, you only need 100 MB of memory per bucket minimum. So if you're running on very low-end hardware and want to create a lot of buckets, you may still want to stay with Couchstore. Again, this is something we are working on reducing for Magma. So with 7.11, it's expected to reduce from the current 1 GB. And this first two bullets are primarily, if you have existing use case, which is a caching use case, and your entire data set fits in memory anyway, or your resident memory to data ratio is anyway higher than 10% or 20% roughly, you can stay with Couchstore. Again, there's no rush to migrate to Magma. It's not disruptive in any way. Like I said, we will continue supporting both these technologies for the foreseeable future. So with that, I'm at the end of my prepared material. So thank you.
No, Shivani, first of all, thank you for coming up and talking about Magma. This is, like I said earlier, it's game changing. This literally will change the way customers think about things, because a lot of times, like you said, it was always about, well, what happens in that case where I have a bunch of historical data that, maybe you're in healthcare and you need to keep that 7 years of patient information. But honestly, the chance of you querying that 5 to 7 years mark, that last 2 years, is pretty low. Well, that's on disk then. And you're not chewing it up in memory, right? There's just savings there in that particular industry.
Yeah, exactly. Precisely. That was the kind of use case we were starting to hear more and more about, because, Couchbase is, as its popularity is rising, people want to use it for more than caching use cases, which is what was the sort of genesis of Couchbase, right? So, so it opens up the gates to all those, archiving use cases, logging use cases, content stores, photo stores, user portals, even user portals. When you go to your banking portal, you are just accessing your last 30 days of activity, right? But your bank stores your activity for whatever, 7 years.
Yeah.
Exactly. So just the last 30 days needs to be accessible at a fast speed. The rest just, can be in disk and accessed at a slightly slower rate.
Absolutely. So we do have a couple questions. So Dennis had came up and asked, is Magma going to replace Couchstore? And I think you kind of answered that in that last slide, saying that, you're not forced to go over to Magma. I think both. And so there's no plans to get rid of Couchstore, right? Can you confirm that?
No, none, not right now. Like I was saying, maybe in 2 years we may, but 2 years, 3 years, but nothing right now. Absolutely not.
So Brian Keane also kind of came in and said, given this, why would you ever use Couchstore, even for memory speed when you have higher regency ratios. Now, I think you gave out several cases why that in the last slide. Once again, and we have to talk about that a little bit to remind people that Magma's new. So, like you said, like there's no full text search, no venting, no analytics. At least today, that's coming very near future, right? You don't need a time machine. That's coming in the very near future. However, it's not there today. So if you're using those features, you want to stay on Couchstore. But there's also something to be said about that caching scenario that we brought up earlier, right? Where you need things in memory because it needs to be super fast. In that, Couchstore is amazing for that. I mean, there's nothing wrong with using it for that.
Magma will work the same because if everything is in memory, Magma will, even when you have Magma as your storage engine, everything will be accessed from memory. So all I was trying for the caching use case is that you are giving Couchstore enough memory to work well. There's no rush to use Magma. But if you have a new use case for caching and you just want to be on the new technology anyway, you probably still can use Magma for caching, 100% caching use cases.
Okay. So here's another question I have. So we have a lot of cool features inside of Couchbase, outside of like eventing, analytics, and full text search. I'll give you examples like collections and scopes, which was introduced in 7, and also user-defined functions and asset transactions. Are all three of those supported in Magma?
Yes.
Awesome.
The only limitations are search, eventing, and analytics. These are not certified yet. It's mostly a matter of our quality engineering team running this test, for large data sets. So like I said, in 7.1.1, which should be out pretty soon, this should be coming. Yeah.
Awesome. So that means that, all that stuff we talked about with eventing, with user-defined functions, all those new features, you could take advantage of those in Magma today. So, that to me is pretty awesome.
In fact, for asset transactions, and this is what this bullet mentions, if you have a use case which requires asset transactions, you probably want to use Magma because of the better performance for durable writes.
That would make sense then, right? Because we're trying to guarantee our rights with. That totally makes sense. Wow. Okay. Very, very cool. So, folks, I think once again, I said it earlier. If you are a Couchbase customer and you say, for example, you're running 6.5, this is the reason to upgrade. I know that in the past, 7.0 came out and the big thing was scope and collections. But when I say that this is the reason to upgrade, this is literally the reason to upgrade. This is the reason and obviously, I'm not telling you to upgrade on Friday afternoon, right? That's a terrible idea. Spin up a POC, bring a subset of your data into Magma and start playing around with it. Get an understanding of the performance gains you're going to get. And of course, if you need to, contact us. Contact the support team. Obviously, we have service engineers that can go through and help you understand what that upgrade means, right? You can engage our engineers. We've got extremely smart people working here, not only building storage engines, but also helping customers migrate their data from these older 6.5, 6.0 releases over to 7.1. So please, if you look at this and you think this is cool, get this in your backlog. I mean, start with a POC. Get an understanding of what Magma means for you. And man, 10 times savings, that's a real number. I mean, that is literally a considerable amount of cash we're talking about, but also a considerable amount of performance, right? We're not talking about just like the money savings. We're talking about performance gains we're getting here, folks. You're getting more data for less, and that's pretty awesome, in my opinion. So I highly recommend if you're excited about this, go on Discord, tell us about it. Go on the forums, ask some questions, but get a POC started. And now is the time to start making that migration plan to get off older technology like 6.5 and get into this new technology stack that's going to give you so much more for your bang for your buck. And that's what it comes down to, right? Everybody knows that in this world, especially today, where, obviously the world's kind of going crazy and the economy is all over the place and stuff, this is where you really can start going in and showing that, hey, we can bring in better performance and also, lower cost, total cost of ownership with this. So this is huge.
All about performance, all about TCO, and at a higher performance. So if you want to really save your money, Magma is the answer.
Very, very cool. Once again, Shivani, I really appreciate you for coming on. Now, folks, I know Magma, like alone, like I said, that would be like most companies put that in a full release. I do want to call out a couple other small things about Couchbase 7.1. A couple of things this is like a launch party, right? It's not just about Magma. It turns out that there's a couple other small things I want to kind of point out. So one of them is in query service. Okay, so query service, one of the things that was happening prior to 7.1 was inside of query. I'm gonna actually just show my screen real quick here and try to explain this so you understand this. So in query service, specifically with joins, okay, we have an optimizer. Every database engine has one of these, right? And the optimizer's job is trying to find information as fast as possible. And a lot of times, if you open up the query analyzer inside of Couchbase Server, in Couchbase Server, by the way, this is how you make one of those super awesome buckets using Magma. It's super easy. I have this up and running. This is from our learning path for Kotlin. So I just have a Docker image running this on ARM64. So this is 7.1. Our learning paths have been updated for that. But inside of Couchbase Server, I accidentally closed it. 1 second here. When you go into the query engine, one of the things you're going to get is you get an explanation. Okay, that's the query optimizer trying to go through and explain it to you what's going on. You also get index advisor. These are important things. Oh, it looks like I accidentally closed my my what's new in Couchbase web page. Let me open that back up real quick. Sorry about that. And let's go through and talk about let's talk about query real quick here. And let me see if I can find the full announcement. I think it's on our documentation page. And of course, I screwed up and accidentally did that. So let's just go to docs.couchbase.com, go to server. If you want to find it the hard way, you can just go and find here, release notes and licensing. If we actually go to reference, nope, I think it's in a release note and release notes. And what's good? Yep, here's 7.1. So this is what I was kind of looking at before. And so query, inside of here, there's a big deal with query. And I want to try to explain this. Enhancements, let's see here, query. Here we go. So I want to talk about this real quick here and try to explain it in layman's terms for you to understand. So in the past, with joins specifically, what was happening is the optimizer didn't always know the optimal order of which go to grab things to get you the best bang for your buck in performance. What would happen is prior to 7.1, whatever order the joins were in your query, that's the order it went and got things. Now, in 7.1, what we've done is that the optimizer knows where all the stuff is, right? That's just how virtual buckets work and stuff. So because of that, it can actually make really good rules about what order it's going to do those joins to get you the best performance. So now we're not saying not only does Magma give you that performance at storage, we're starting to talk about here in the query engine, we're giving you index and also performance in here with the optimizer and going through and basically optimize your join so information comes faster, better. Now, some people will say, well, wait a minute, Aaron, you're changing you're moving my cheese. You're taking it, I had this behavior that I got used to and I don't like that. Well, that's where optimizer hints come in. What the optimizer hints allow you to do is basically at a query level say, you know what, I want you to use this index, or I want you to do things like this instead. So you literally could tell the query optimizer, you can give it, hey, you know what, maybe I have 4 queries, but 4 indexes, but I know very specifically I want to use this specific index. With the hints, you can actually do that. This is another new 7.1 feature. So when we start talking about 7.1, this is a massive change. It's for Magma. We're talking about there's performance increases all over the place. So we talked about memory cache ratios, all these other things, but also the query engine's pretty big. There's, like I said, the user-defined functions. There's a big thing in there. And also for analytics, if you're an analytics nerd, this is awesome for you because in this new release, we have Tableau connector now that's supported. There's a bunch of new things in analytics that really you need to go through and look at. So when I say 7.1 is a big deal, it really is. And I'm going to go to developer.couchbase.com real quick here. We do have a highlights of what the developer advocates picked as our favorite features. Obviously, I talked a little bit about the ARM support. I've talked about analytics. You should go check that out. Magma is the biggest deal. That's why it's first here. We talked about user-defined functions. I think the query stuff is pretty big. And also there's some stuff with indexing, which I was kind of just hinting towards there. And so my recommendation, once again, go through, check out our documentation, go through, spin up that POC and check out 7.1 because it really is going to provide you a massive amount of value for what you're going to pay to upgrade your clusters. And, once again, if you have problems with that, just ping our team. go through and open a support ticket. Hit us on Discord, hit us on the forums. Obviously, there's so many different ways you can talk to us about if you have questions about doing your migration. With that, folks, that is going to be our meetup for this month. I'm really happy about Magma. I'm really happy about this kind of new features that we have. I think it's really exciting for customers, and this is going to be a big deal. It's going to change the way that people look at Couchbase for years to come. So I appreciate everybody for attending, and I hope you all stay cool, stay safe, and we'll see you on our next monthly meetup. Take care.